we can use integration to find the area underneath a curve. So here we've got the graph of y equals x times x plus 3 times x minus 3. And we need to find the area of the region R. So we need to find the area between 0 and -3. So what we want to do, to use integration, is the integral between 0 and -3 of x times x plus 3 times x minus 3 with respect to x. So that's our calculation. To integrate this, we are going to have to expand the brackets. So x plus 3 times x minus 3 is the difference of two squares. It is x squared minus 9. And we've got x times x squared minus 9. So that's going to be x cubed minus 9x. So now we can integrate, add 1 to the power, divide by the new power. So we've got a quarter x to the power of 4 minus 9 over 2 x squared. And we've got the two limits, 0 and -3. So we can substitute in 0 and substitute in -3. So we've got a quarter times 0 to the power of 4, which is 0, minus 9 over 2 times 0 squared. So that is 0. Take away a quarter of -3 to the power of 4, minus 9 over 2 times -3 squared. And we can type this into our calculator. So the first bracket is just 0, and it's take away a quarter of -3 to the power of 4 minus 9 over 2 times -3 squared. And we get 81 over 4. So that's our answer, 81 over 4. And I'll just write, because it's an area, I'm just going to write units squared. We could, of course, have used the calculator to do the whole thing. So alpha x times x plus 3 times x minus 3 between 0 and -3 is 81 over 4. Here's one for you to try. Pause the video, give it a go. Try and do it without a calculator, because they can always put a letter, a constant, in the question. So we need to be able to do this process. So we've got x times x minus 4. We can see it crosses the x-axis at 0 and 4. And we want to find the area between those two. So it's the integral between 4 and 0 of, if I expand the bracket, x squared minus 4x with respect to x. So add 1 to the power, divide by the new power, 1/3 x cubed. Add 1 to the power, divide by the new power, minus 2x squared, square brackets, and the limits. So we substitute in 4, substitute in 0, and take them away. So 1/3 times 4 cubed minus 2 times 4 squared. And then it's going to be take away, the second bracket will be 0. So we've got 1/3 times 4 cubed minus 2 times 4 squared. So we've got a negative answer here, 32 over 3. And that's because it usually means the area, well, it means the area is underneath the x-axis. And the reason is the equation doesn't match the graph. So it should be negative x times x minus 4. So If it is x times x minus 4, it's a positive quadratic, and it's the same area, but underneath the axes. The answer is 32 over 3. So 32 over 3 units squared. So when we get a negative answer out, it just means that the area is underneath the x-axis. If we had a minus here, a negative, both of these terms would have been, well, it would be negative x squared plus 4x, and we'd get exactly the same answer, only it'd be positive. So this time we have 32 over 3 units squared as our area. Either way, for either equation, for y equals x times x minus 4, or y equals negative x times x minus 4, the area is the same. The only difference is whether it's above or below the axis. Here's another one. So we've got 4x squared plus 12x plus 13. Find the area of the region. So again, it's the integral between 3 and 1 this time, between the two limits of 4x squared minus 12x plus 13 with respect to x. So integrate, add 1 to the power, divide by the new power. So 4/3 x cubed minus 6x squared plus 13x. And we keep the limits there. So substitute in 3, substitute in 1, and take them away. So 4/3 times 3 cubed minus 6 times 3 squared plus 13 threes. Take away 4/3 times 1 cubed minus 6 times 1 squared plus 13 times 1. Type it into the calculator. We could work it out. It's probably easier to type it into the calculator. So I'm going to do it without typing in. So 36. 9 times 6 is 54. 13 times 3 is 39. And we've got 4/3 minus 6 plus 13. It will be easier to type into the calculator. So I've got 36 minus 54 plus 39 minus 4/3 minus 6 plus 13, which is 38 over 3. So 38 over 3 units squared. I'll check my answer. So I've got 4x squared minus 12x plus 13. And that's between 1 and 3. So 38 over 3. One for you to try. Pause the video, give it a go. So it's the integral between 3 and 1 of x cubed minus 2x squared minus 5x plus 6 with respect to x. So we integrate. So we can type this in the calculator straight away, but we need to be able to do this process. So it's important that you can integrate and substitute the values in, because there might be a question with a letter in it, and in that case you won't be able to type it into the calculator. So from typing into the calculator, we've got a negative 16 over 3. So again, that should mean the area is underneath the graph. And again, from looking at it, we can see that the graph is wrong. It should be, this is a negative cubic. we should have this is a positive. The equation is for a positive cubic, but the graph is a negative cubic. So if the equation was, so the answer's right for either one. So if it's a positive or a negative cubic, the area would be the same. The only difference is for this graph, for the question we've answered, the area would be underneath the graph. It would be flipped over the x-axis. It's like when you have the transformation negative f of x. So all of the y values, positive y values, become negative y values. That'll be exactly the same area. Maybe a reflection. Exactly the same area, just underneath the axis. So it should be 16 over 3 units squared. Find the area of the finite region, so the region between the curve and the equation, y equals x squared times x plus 3, and the x-axis. So this time we haven't been told the points where it crosses the x-axis, but we want the finite region. So we've got our graph. It crosses x when y equals 0. That'll be at 0. And at negative 3. It's a positive cubic, and it's got a repeated root at 0. It's a positive cubic, so it comes up, repeated root at 0, and then keeps going. So the region we're after, the finite region between the curve and the x-axis, that's this region here. That's our region. So we want to integrate between 0, the limits are 0 and negative 3. That's the integral between 0 and negative 3 of, if I expand the bracket, x cubed plus 3x squared with respect to x. So that's our calculation. Add 1 to the power, divide by the new power. So a quarter x to the power of 4. Add 1 to the power, divide by the new power, plus x cubed between our two limits, 0 and negative 3. Let's substitute in 0, which is going to give us an answer of 0, and negative 3, and type it into the calculator. So we've got the first bracket 0, take away a quarter times negative 3 to the power of 4 plus negative 3 cubed. So we've got 27 over 4. So 27 over 4 units squared. And we can check on the calculator. So it was x cubed plus 3x squared between negative 3 and 0. And I've missed out the cubed, which is why the answer is different. Cubed, so 27 over 4 units squared. One for you to try. Pause the video, give it a go. So find the area of the finite region between the curve and equation x times x minus 4 squared and the x-axis. So this time we've got roots at 0 and 4. The repeated root is at 4 this time. That's the one that's squared. And it's a positive shape. So it's up, touches at 4, and then goes up again. So our region is the bit that's enclosed. So between 4 and 0. So we're integrating between 4 and 0, and it's x times x minus 4 squared. So x times x squared minus 4x plus 16. So it's x cubed minus 8x squared plus 16x with respect to x. Integrate, add 1 to the power, divide by the new power. So we're going to have a quarter x to the power of 4 minus 8/3 x cubed plus 8x squared. Substitute in the 4 and the 0. So a quarter times 4 to the power of 4 minus 8/3 times 4 cubed plus 8 times 4 squared. And then the second bracket is just going to be 0. So we have a quarter times 4 to the power of 4 minus 8/3 times 4 cubed plus 8 times 4 squared, 64/3. And I'll check the answer. So I've got x times x minus 4 squared between 0 and 4, 64/3. So this time we've got a letter, which means we wouldn't be able to use the calculator. This is why we need to know the process. So here is the graph, y equals x squared. The area bounded by the graph, the x-axis, and the line x equals k is 9. So the area equals 9. Work out the value of k. So we've got the integral between k and 0 of x squared with respect to x is 9. We need to find out what k is. So integrate, add 1 to the power, divide by the new power. Got the limits between 0 and k. But then we substitute in. So a third times k cubed minus a third times 0 cubed, which is 0, equals 9. So we've got a third k cubed equals 9 times by 3. So k cubed equals 27. And so k is the cube root of 27, which is 3. So k is 3. One for you to try. Give it a go. So we've got a graph of equation y equals 3x squared. The area bounded by the graph, the x-axis, and the line x equals k, again, is 8. Work out the value of k. So the integral between k and 0 of 3x squared with respect to x is equal to 8. We're going to integrate, add 1 to the power, divide by the new power. That's just x cubed. Between k and 0 equals 8. Substitute in, so k cubed minus 0 is 8. K cubed is 8. K is the cube root of 8. So k is 2.